Hi everyone. We're going to talk today about the domain and the range and what that is and how it applies to graphing. And so before we start, I want to just kind of show you something that we've been working on for maybe a couple of years. Let's say that you had x plus 5. And let's say that I wanted you to substitute the number in, say 3 for the x value. Then you would just change the x to 3 plus 5 and you would get 8. So what you actually did was you could actually say that this is a coordinate or an ordered pair. And when you took 3 for x, you came out with an answer of 8. And so you could call that your y value. And so that's kind of what we're going to take a look at in the next couple of lessons. So let's go to this table that I have here. So in this table it says we're going to talk about the weight of cats. So the age is going to represent the x and the weight is going to represent the y value. So actually what you have here is you have a coordinate. This coordinate is 1, 2. This one is 2, 3. This one is 3, 5. And then we have 4, 8. I'm running out of room. And then 5, 8. And then 5, 10. And so that's all these are. They're just coordinates. So sometimes you're going to see the table written horizontally. Sometimes you're going to see it written vertically. But this is your x value, your y value. Usually your x value is on the top, or if your table is written vertical like this, then your x value would be on the left and your y value would be on the right. And another way that they talk about these x and y values is they can call the x value the input. So I'm going to write input. And the y value is called the output. And the x values are also called the domain and the y values are called the range. And we're going to talk about that in just a minute. But let's go on ahead and take these ordered pairs, coordinates, and let's graph them. So the first coordinate that I have is 1, 2, and then I've got 2, 3, and then when this particular cat was 3 years old, it weighed 5 pounds. And so this is my x value, this is my y value. And then when the cat was 4, it weighed 8, 6, 7, 8. And then when it was 5, it weighed 8. And then also, when it was 5, it had quite a weight gain. And it went all the way up to 10. And so these are the coordinates that I plotted for this particular table. And so now, let's talk about what the domain is and what the range is. It's very, very simple. The domain is the set of x values. So I'm going to write this brace, and then my x values are 1, 2, 3, 4, 5, and 5. And notice how I have a repeating x value. Well, when it repeats, in the domain, you're not going to list it twice. You're just going to list it once. Also, when you write your domain and range, put them in order from least to greatest. Okay, my range is the set of y values. So it's really easy. So I just look at my table and my y values are 2, 3, 5, 8. Notice we have another 8, so I'm not going to write it twice. And then 10. And that's all there is to the domain and the range. So the domain are your input and your x values, and your range is also called your output and your y values. So very, very simple. So what are we going to do with this? Well, one of the things that we're going to talk about is a relation. These points have a relationship on the graph. Sometimes we see tables and we don't know what the data represents, but this time we do. We know it's the weight of cats. And when we graph it, there's something special that we're going to be looking for. And I'm going to borrow this arrow here, and I'm going to come over to the graph. And this is called the vertical line test. And sometimes I call that the VLT, but it stands for vertical line test. And what you're going to do is you're going to take your arrow and you're going to move to the right. And so far I'm good. What I'm looking for is to see if I'm going to hit points, more than one point at a time on my graph. And so I'm moving, everything's looking good. And then I get right here and I hit 1 point. So that's good. And now I'm going to keep moving to the right and I hit another point. So that's good. And then I hit another point and then another one here. But then when I get over above the 5 on the x-axis, I hit 2 points. When that happens, this is called a relation. And we're going to talk about relations and functions. So when points stack on top of each other, it's called a relation. When points don't stack on top of each other, say that this particular point was not on the graph, and I did my vertical line test. As I move across, I just hit 1 point at a time vertically. So when this happens and you don't intersect, there's not 2 points stacked on top of each other, then it's called a function. And we're going to talk about that a little bit more. So let's take a look at something else that we can do with this particular table. So you know what the domain is at your x values, you know what the range is at your y values. So let me show you something else that you're going to do with those. Besides a table and besides graphing your data, you can also make something called a mapping diagram. So a mapping diagram looks like 2 ovals, and this one is your input and this one is your output. And remember, your input is your domain and your output is your range. So I could call it domain and range, or x and y. So what I'm going to do is I'm going to drop my x values in for my input. So I've got 1, 2, 3, 4, and 5. And again, when I have a repeating number, I'm just going to list it once. I'm not going to repeat it. And now I'm going to drop my y values in for my output. And again, I'm going to put them in order from least to greatest. 2, 3, 5, 8 repeats. I'm just going to list it once, and 10. And now what you do is you match them up. So 1 goes with 2. So I'm going to draw an arrow like that. And then 2 goes with 3. So I'm going to point to the output number that 2 goes with. And then 3 goes with 5. That's easy. And then 4 goes with 8. And then also 5 goes with 8. And 5 also goes with 10. So, again, we said that this particular graph of this table was a relation because over on our graph we had a set of points that stacked vertically. And in a mapping diagram, when you have a number in the input, or the x value, that goes with more than one number in the output, that means that it's also a relation. So let's look at a couple more of these so that we can get used to this and see how easy it is. Okay, in this particular problem, I had a set of ordered pairs, and I'm going to go on ahead and graph them. So I've got -4, 2. So you start at the origin and move left, which is negative, and then 2 is positive, so you go up. and then I've got 2, 3, and then 4, 8. Okay, I'll put an 8 right there. And then 0, so I stay in the origin, I go straight up 3. And then -2, +2. All right, so here are my coordinates on my graph. So let's go on ahead and do the vertical line test and see if we have any points that stack. So as I slide from left to right, I just hit 1 point, 1 point, 1 point, 1 point, and 1 point. When I just hit 1 point vertically at a time, this is called a function. So rather than it being a relation, this is more specifically called a function. And it just means that it passes the vertical line test, that your points don't stack. It's really easy to tell if you have a function, super easy. All you have to do is look at the x values. I'm going to underline all my x values in my coordinates and just make sure that none of those numbers repeat. Well, I've got -4, 2, 4. I know I have a 4, but it's negative, so these are totally different numbers. They're opposites. And then I have 0 and -2. So all of these numbers are unique. And when all of them are unique and they don't repeat, you have what's called a function. It just means when you graph it, the points are not going to stack on top of each other vertically. So let's do a couple of things with this. Let's go on ahead and identify the domain. So remember, in a coordinate you have the x first and then the y. So my domain is my x values, and I'm going to try to go on ahead and put them in numerical order. So I'm just going to scan really quick. -4 is my smallest number, and then I've got a -2, and then a 0, and a 2, and a 4. See how easy that was? And now I'm going to write my range. If your range has repeating numbers, that's fine. It can still be a function. It all goes by the domain. The domain numbers all have to be unique and not repeat. So now I'm going to list my range. My range are my y values. And let me circle those really quick. So super easy. Okay, so there's my range, or my output, my y values. So let's see if we can get them in numerical order. It looks like 2's the smallest, and I've got 2 of those, and I'm just going to list them once, and then it goes to 3, and I've got 2 of those, I'm just going to list it once, and then I've got my 8. So here's my range. And now let's go on ahead and make one of those mapping diagrams. So we're going to make 2 ovals. And we can go right on ahead from the domain list that we have of our x values and the range list that we have of our y values. We can go on ahead and just drop those in. And again, you drop them in numerical order. That was easy. And now I have to match them up. So when I match them up, I want to go back and look at the coordinates. So it says 4 goes with 2, and 2 goes with 3. So see, I'm having to go down to +2. Okay, 2 goes with 3. Woo, getting a little tricky. And then 4 goes with 8, and I'm pointing toward the 8, point toward my y value. 0 goes with 3, and then -2 goes with +2. And so this is my mapping diagram of these coordinates. So we can have the coordinates listed this way, or you could have them in a table where you take them out of a table and then you write the domain and the range and the mapping diagram and move it to a graph. So easy. Let's try another one. In this particular set, I have a table. And so what I'm going to do is I'm just going to go on ahead and list the coordinates. So I'm going to take out 4, 0, looks like a 6, and then 2, -1, -3, 0, 4, -1, and -4, 0. Now let's write our domain. So my domain is my input, or my set of x values. And you can write it in a set like that, or you can just list it like this. So my domain are my x values. All right, so let's scan this for the smallest one. It's -4 right there. And then the next smallest one, oh, it's -3. Okay. And then I've got a 2. And then I have 2 4s. And so I'm just going to list it once. And then my range, that's just my y values. That's all it is. So my y values, let's see if I can find the smallest one. 0s and -1s. Okay, that's easy. -1. And, yeah, just verifying that I got them all. All right, so we have the domain and the range. And now let's make a quick mapping diagram. So this is my input. And this is my output. So all we're going to do is move the x values into the input and the y values into the output. So my domain is already in numerical order for me, so that makes it easy. And there's my range. Okay, let's match them up. 4 goes with 0. 2 goes with -1. -3 goes with 0. 4 goes with -1. Woo! And -4 goes with 0. Wow. All right, so let's take a look at this and determine whether this is a relation or whether it's a function. So what I'm going to do is, all I have to do is look at the x values. Y's I don't have to look at, but x's, I've got a 4, 2, -3, 4. Uh-oh. These two guys right here, they're the same. So there is a relationship between these points. And if I come over here and plot these, you're going to see that they're going to stack. And so that's going to make it a relation and not a function. So 4, 0 would be right here. 2, -1 is there. -3, 0. 4, -1, and see the stack. And then -4, 0. So again, if I do my vertical line test, crosses this point, hits 1 point, 1 point, 1 point, and then when it gets over here, 2 points stack on top of each other. So this one is not a function. It is a relation. So very easy. It's great to graph your points so that you can see them stack on top of each other and just verify, yes, these stack vertically, so it's a relation. All right, let's take a look at a couple more things. In this particular graph, the blue V is my graph. I'm going to check and see if it passes the vertical line test. So as I move over, I'm just passing 1 point at a time. There's not anything stacking on each other. Even when it gets down here, it just hits once. And as I continue this way, no points stack on top of each other. So this one is a function. Let's look at another one. Let's say that I had a circle. All right, let's make it a smiley face. There we go. So as I move vertically, you can already see that it's going to touch here and here. So as I move vertically, I do have points stacking on top of each other. So this one is not a function, it's a relation. Let's look at another one. Say that you had this. As I move vertically, I'm just hitting one point at a time. This is actually a function also. And now let's put a couple of coordinates on here. Let's say we had all right. So as I move vertically, I'm hitting 1 point, 1 point, 1 point, 2 points. So as soon as I have 2 points that stack on top of each other, it's going to be called a relation rather than a function. So basically, this is a good introduction to the domain and the range. And if you had to identify the domain and the range from a graph, it would be super easy. All you would have to do is identify the location of the coordinates. And let's see, this one is at 1, 2, 3, 4, 5. The first one is at -5, -2. And this one is at -3, +2. And I'm just moving toward the right. And this one is at 1, 4. And I'm going to go on ahead and stop with that. And so all you would do is take your coordinates and then go on ahead and list the x values as your domain. And so your domain here would be -5, -3, 1, and then so on if you listed the remainder of the coordinates. And that's a good introduction to domain and range and also relations and functions, and we're going to continue to build on this and work on functions. So thanks for joining me today, and check out my other videos.